Switches are normally connected to microcontrollers. They are a common component and we need to learn how to connect them properly to our microcontroller. With our microcontroller, let's say this is our input. In order for the input to be either a high or low, we need to connect it to either a positive 5 volts. So in this case, our microcontroller would see this as a logic high. If what we do instead is connect it to our ground, then our microcontroller will perceive that as a logic low. So if we take this input of our microcontroller, connect it to ground, microcontroller will see that as a low. We want to be able to control that switching between a high and a low with a switch. So let's take this and let's put our switch in here. So we'll have our plus 5 volts. We'll have our switch and we'll connect it up to our input. So you would think that this would be correct and that when we close the switch we have our connection to plus 5, so our input would then see that as a logic high. That would be correct. That when we open this switch, since it's not connected to plus 5, you would think that would be a logic low. And this would be incorrect. This input is referred to as floating in this particular instance because it's neither plus 5 and it's not definitely being pulled low. It is floating. It could be at plus 5, it could be at 0, it could be any place in between. So we don't want to leave it like this. So you may say, well, let's simply add a connection to ground so that when we're not pressing the switch, this input is being pulled low. So we would have the input seeing this as a low. And when we press the switch and close the circuit, we'd be making the connection to plus 5 volts and would be seeing a high. But this would not work because now we've made a connection directly to 5 volts and the ground, shorting out our power supply. So this is no good. We need to be able to do this, but without shorting our power supply. So what we've got to do is put a pull down resistor in here. So this is of no specific or certain value, but this will be a 10K ohm resistor, something of relatively high resistance. So now when we close the switch, it will see 5 volts on the input, but we're not going to be shorting out the power supply. So this resistor will serve to limit the current when this switch is closed, but yet when it's open, allow it to be pulled low. So this is how we want to connect our switches. Now there's an alternate way, depending upon whether we want the switch being closed to generate a high or the switch being closed to generate a low. We can take this switch and put it into an alternate position. So let's take these two components and switch them out. So let's put our switch in here. Oh, let me do that a little better. So we've got our switch in here, and we're going to put our resistor, our pull up resistor, in here, again about a 10K. So now when the switch is pressed, this will generate a logic low. When it's not being pressed, it'll be pulled up to plus 5 volts, and so it'll be a high. Now sometimes what you'll also see is a second resistor placed in here. Technically, it's in most cases not required. Let's say it's about a 1K, something a little bit less. And the primary reason you'll see this is that if somebody were to make this an output accidentally and program this as an output, we would not want to turn on this output and have it make a direct connection to our ground if that switch were pressed, because then again we would be shorting out our system here. So this serves to limit the current in case that mistake in programming or in wiring it up were made. So not necessary, but in many cases not a bad idea either. All right, so let's see how we do this with our development board. So this is our development board, our microcontroller. Here are some switches that are on board. We don't have to use these, but we're going to use this for the example. And so what we need to be able to do, let's say we're going to do it as we did in the first example, where we had the 10K going to our ground. So this row of contacts are for these switches, so there are 2 for every switch. This row, or the header, is for the other side of these single pole, single throw switches, and there are 2 connections for every one of those. These are simply connected to each other, so we could use either one of these holes, Same thing over here. So we're going to get our, let me change my color here. Let's say that we're then going to put in our 10K from, remember our ground is on this side, and so we would have our resistor in here, and let's go to that top switch. So this is my 10K. So we have that 10K going from ground to the switch. We also need a 1K going from that same part of the switch to our port. So let's take and go from here. We're going to have our other resistor, and let's say we choose that particular port. And so then this will be something like the 1K. The other connection that we then need to make is from the other side of the switch to the +5. So I'm going to change the color here to yellow, just so when we go from our +5 volts, I can see a little bit better when it crosses over there. So I know this is a little bit confusing, but what we have is a connection from our positive side to our switch. So whenever our switch is closed, that input will be seen as high. And this is our limiting resist here in case we were to make a mistake and program this as an output. This is our resistor that is connected then from the other side of the switch to our ground. That's going to limit the current whenever we close the switch between the positive 0.5 and then to ground. So we would do that for all of our other switches then. Now remember that this one is optional. If we weren't going to use this resistor, we would make a direct connection from the switch to the port. Okay, I hope that explains then how to connect your switches to the Pickaxe development board.